All right, chain rule. Let's do it. Day 7. The chain rule. Now, I always say this when I go to start the chain rule is we know how to do power rule. We have memorized many different derivatives. We know derivatives of trig. We know how to do derivatives of product rule. We know how to do derivatives of quotient rule. And we probably feel like I could take the derivative of like almost anything. I mean, like, what else is there? I know how to do square roots. I know how to do trig. But the reality is there's one giant gaping hole in our derivatives ability that chain rule is going to kind of fix. Now, the good news is chain rule by itself is not a difficult rule at all. But chain rule, when you introduce this, because it's not a difficult rule on its own, it often gets paired with other rules. So you'll have a question where you need chain and product. And then all of a sudden, it gets kind of ugly. So let's talk about chain rule before I spoil the ending. Chain rule. I guess we'll just do the rule itself here, which is not very complicated. If f of x is equal to g of h of x, so already starting off, chain rule, given this intro, chain rule is working with function composition. Chain rule is working with function inside of a function. And it probably has almost, like I said, flown under your radar that we haven't done any questions like that with complicated things inside of a square root or inside of a trig function, things like that. So how does it work? F prime of x is going to be g prime, I guess I'll do it like this, g prime of h of x. So you're going to take the derivative of g prime, or derivative of g, which is g prime, but the h, you're just going to leave alone. Now, if we pause here, that makes it seem like, okay, who cares about the chain rule? If there's a function inside of a function, you just ignore it. So there is another part to it. Times, or maybe I'll just do a little dot here, that's fine, h prime. So what ends up happening is when you take the derivative of a function, if it has another little function in there, you start off and you just kind of ignore that function. You just leave it alone. You don't change it at all. But then once you've finished taking the big derivative, it just ejects that interior derivative. So at first, it kind of seems like things are just popping out of nowhere because literally you're just kind of ignoring the chain rule and then you just put the derivative on the end of it. So let's see this real quick. Let's say that for our first question, f of x is equal to x squared minus 2x squared. So this is all it takes to make a chain rule. This looks like a nice power rule. We take the 2, we put the 2 in front, we take 2 minus 1, and make, whatever. But the inside here, it's not just a plain old x squared, it's a x squared minus 2x squared. So that inside function is more interesting. So we're going to start, when we take the derivative, by doing the boring old power rule, and you're almost going to ignore that anything in there exists. You're going to keep it, but you're going to ignore it for now. So we're going to do the power rule. Put the 2 out front. Take your 2 and subtract it, so you're going to get a 1. We don't need to write that. And then this x squared minus 2x, don't touch it, don't change it. It's the inside, it's the little baby, leave it alone. do the normal power rule. Cool, that's the derivative, but chain rule, we need to eject the derivative of that interior function, which would be 2x minus 2. And that's the chain rule. Now, maybe do a little bit of simplifying. As usual, you kind of have to get a feel for how far do we need to go, what is it worth. Clearly, distributing 2 is an easy thing. We also could FOIL this. 2x squared minus 4x, 2x minus 2, and then, we could FOIL that. F prime of x is equal to 4x cubed. That's going to be minus 4x squared. That's going to be minus 8x squared. That's going to be plus 8x. And so final answer here, f prime of x is equal to 4x cubed minus 12x squared plus 8x. All right. So, we did our chain rule. Leave this part alone and then eject out the derivative. Any issues with how that worked? Let's do just a little bit of a proof, because I'll do a little bit, oh my gosh, a little bit of an or. This function, x squared minus 2x parentheses squared, is a function that instead of jumping straight into the derivative, maybe we could just do some algebra first and it would make this look a lot easier. So we could, before we started, square this little binomial, which would be FOIL this binomial. So no derivative, just algebra here. That would be x power 4 minus 2x cubed minus 2x cubed, which is going to be minus 4x cubed, and then plus 4x squared. That's just foiling, right? No derivative so far, only FOIL. And then, now it's a super easy derivative. Now it's a power rule. And so f prime of x is equal to 4x cubed minus 12x squared plus 8x. And of course, these are the same thing. Two different ways to do the same problem. It's kind of showing you that, yeah, the chain rule does work how it's intended. If we had left off this ejected derivative, of course, we wouldn't have been anywhere near the original over there. And so chain rule works. That's how it works. This is, a little bit of an example. This thing over here, sometimes, can you do a question maybe a little bit easier with algebra? Maybe. If it was a question like this where it's just squared, it probably is easier to just square a binomial and then do the power rule. That means normally when you do get a question, they're going to put a cubed instead of a squared, or they're going to put a power 4 or a power 5 or a power 6. You definitely don't want to be doing binomial expansion of a power 6 function, and we don't really want to be messing with that. So it's kind of up to you how you do it. I would say if you're doing chain rule homework, probably use the chain rule, build up that practice and work on it. And then once you get to a test, or if you get to an IB paper or something, and you need the derivative, but this chain rule, you just can't quite make it work, and maybe a little bit of elbow grease, you could do this, maybe you could make it happen. Now, obviously, this works because it could easily be turned into a polynomial, but there are other questions where you can't really do much to make it look nicer. Let's do, I went crazy with the letters today. I don't know what was going on, but we're going to do w of x. So for this one, let's think about this. Think about, okay, there is an interesting function on the inside of the square root, but if that wasn't there, we could do our typical derivative of a square root, right? We know that if y is equal to the square root of x, then dy dx is 1 over 2 square root x. We've memorized that. This one is very similar, except for that inside is a little bit more interesting. When we do the derivative, we're going to basically ignore that it has an interesting interior function. It is still going to be 1 over 2 square root x, but it's not going to be x. It's going to be 3x minus 2. And then after we've done that, it's going to eject, you're welcome, the derivative of that interior function. So what is the derivative of that interior function? Just 3. And then where does this 3 go? It just goes kind of like at the end, right? It doesn't go on the bottom. Some people say, oh, well, the rest of this stuff went to the bottom, so maybe that's not how it works. It goes on the end. And you might be you probably are a smart enough calculus IB student where you can say, sure, the 3 goes on the end, but it would probably look nicer if we put it on the top. Because, the 1 is a top number and the 3 is like a 3 over 1 and whatever. So typically, this would be a nice final answer for our question here. That 3 is the derivative 3 that kind of got spit out. Any issues with that question? Again, thinking about it and doing this and seeing these, the chain rule, chain rule is not all that bad, right? Just take your time, make sure you're doing the derivative of that inside function. Now, really quick, before we move on, how come the chain rule, which exists, we don't talk about, we don't learn for the first 2, 3, 4 days of derivatives? How come we were doing this derivative and we just never even knew the chain rule existed? If we're doing the chain rule of this function, we should do the chain rule on every function, right? What if we do the chain rule on this original simple version, just y equals square root x? So, okay, we just take the derivative and we leave the inside alone. And then what is the derivative that gets ejected out of there? Just a 1. Just a 1. And so basically, it has a trivial chain rule because the derivative that it's spitting out is just a 1. And so who cares about that, right? And so same as like, y equals sine x. All right, so that's y prime equals cosine x. But also, oh wait, that x has a derivative. What's the derivative? A 1. And it's like, who cares? So that's why we don't do chain rule until the end. I just give you a bunch of trivial chain rules to start while you're working on this. And now we learn it retroactively. It still existed. It was just a waste of time. Okay. Now, we've done a lot of talking, or maybe not we, but I have done plenty of talking. Time to just power through some examples and be done with derivatives and learning derivatives. We're not done with derivatives, but done with the learning how to take derivatives. So very similar to the one that we just kind of threw up on the board a second ago, sine of x, but this time we have an interesting function that is inside that sine function. So v prime of x is going to be, I'll give you guys a second or two, and then why don't I have somebody shout out the answer when they feel okay about it? Anybody get to an answer? All right, if we're not to an answer yet, then there's probably a little bit of a disconnect one way or the other, or maybe we're just intimidated by the process, because this is a question that at this point is hopefully bringing no added difficulty besides just a little bit of what goes where. So when I look at this, I'm seeing the sine function and I'm thinking, that's it, easy, derivative, cosine. So I've already got half the question finished. I know the derivative of sine is cosine, great. Then I look inside here and I say, you know what, this is an interesting, non-trivial interior piece of the function. So I'm gonna start by kind of putting a lock on that. I don't wanna touch that yet. I'm gonna do the sine, I already know that is the cosine. This, which I locked down, I don't want to change it yet. I just need to eject out its derivative, which again is a in my head derivative, not difficult. That's going to be 9x squared minus 2. And that's the whole thing. Right? It's really a question that should be just done in our head. The one thing we're trying to organize is, you know, what goes where. Lock this down, don't change it, then eject out its derivative. We feel okay about that?
Should we be foiling those two or just leaving it?
Right now? Like at this point you're saying? A very good question. These cannot be foiled. It would be illegal to do that because this is the cosine of that thing. It is not just a normal old plain thing. So if it does look foilable over there, but this is the cosine of it. So yeah, definitely can't mess it. The best we could do here is probably do a little bit of reorganizing, just because that looks a bit better, specifically because it looks properly unfoilable now that we reorganize it in this direction. There we go. Maybe that looks a little better, but I mean, I'm not really caring about it. Okay. It's not a long question. Takes one little line, we're done. Let's do z of x. Like I said, I was just alphabet soup making up these questions, I guess. Let's do cosine of sine of x. Again, do this derivative. It should be 30 seconds. It really should not be a real thinker. Z prime of x is equal to cosine, easy. That's negative sine. I'm thinking this. I'm thinking, okay, this is an interesting non-trivial derivative, so I'm going to lock this down for the time being. It's going to be negative sine, leave this alone, sine x. Then, oh wait, I had that interesting inside. It needs to eject out its derivative, cosine x. And I think that's a good enough way to write this one. I don't think we're really gaining too much by rewriting it. Again, you know, maybe we could put this, you know, I don't really see the value in reorganizing it in that way. I don't think it really looks all that much better. So not too worried about that. Now let's really quickly do a very similar question. What if we had I'm running out of letters here. G, B, H, I, J. Let's do K. You gotta think hard to pick a new letter. Let's do K of X is cosine of sine of 3x. Basically, it's the same exact question. Z and K are almost the same, but they're not quite the same because I'm noticing that we have the same thing, an interesting, non-trivial interior function here. Gonna put it on lock. I'm gonna leave it alone. So K prime of X is gonna be cosine. Well, the derivative of cosine is negative sine. Leave this stuff alone. Sine of 3x. Then I need to eject out the derivative of that. But when I go to look to eject out the derivative, I'm noticing, wait a second, this is an interesting, non-trivial interior function. So let's put a lock on that. The derivative of sine is cosine. And then it should eject the derivative of that. So there's a function with kind of two layers, you know, layers within layers of chain rule. And that's where it's all about taking your time. Notice that you have those layers. Now, sometimes when we're doing algebra, it is easiest to, when you notice all of these layers, start working from the inside out. When we're doing chain rule, I really recommend just work on it outside in. Just do the derivative of the big function and then consider the inside function. And if you need to, then again, consider the inside function. So the inside out stuff doesn't work quite as well for chain rule. Okay? Okay, now we're going to elevate into questions considerably harder than those that we've been doing. If those were, I'll just tell the teacher I'm okay, even though secretly I am not doing okay. Time for some questions if you're not seeing where this stuff is coming from. Y is equal to 5x squared minus 1 power 4 times 2x minus 9. Like I said before, chain rule, not that difficult. In reality, it requires you to do a boring derivative that you already know, and then eject out probably also another boring derivative that you already know. And so it's a procedure, but not a difficulty. So what that normally means is they're gonna add that together. They're gonna make a combo problem where you've got product and chain, quotient and chain, or maybe just chain and chain, or something like that. So for this question, I'm looking at it, I'm noticing we have this piece, power 4, and this piece, power 1, right? Power nothing, really. These two pieces are being multiplied together, so I'm thinking it's going to be product rule. But also, this piece is kind of a function within a function, right? It could be just x power 4, and then we would just do a normal power rule, product rule, but it's not. It is a whole thing power 4. So that is going to require us the chain rule. This also kind of looks like that very first question we did where we realized a little bit of algebra first can save us a lot of calculus. Do we want to try this one with algebra? No. This is something, a binomial power 4, and yuck. I don't really want to mess with it. Even if I did binomial expansion for this power 4 binomial, then I would have to incorporate this second binomial and I would have to FOIL this algebra. No way. We're using calculus. So here we go. dy dx. You always want to kind of consider chain rule as like the secondary thing. Like we want to do product rule. And if we need chain rule, then chain rule will happen. But product rule is our primary directive. And remember, product rule is derivative of one, leave the other one alone. Leave the first one alone, do the derivative of the second. So For this, I'm going to start by taking the derivative of this first function, which has a interesting non-trivial interior function. And so my derivative is going to be 4 times 5x squared minus 1 cubed, parentheses, 10x. That is my derivative of the first bit. It didn't take me very long. I could do it all in my head. Where did all this come from? The 4 comes out front because it's power rule. The 4 drops down to a 3 because it's power rule. But remember, this inside is interesting and non-trivial. So what's the derivative of that? It's 10x. Spits it out, and we're pretty good to go. Now that is only 1/4 of the things we need for the big product rule. Again, chain rule is like something we use when we need to, but we're really focused on the product rule. So if this is derivative of the first, product rule says it should be multiplied by the original of the second. Then we need to add that with, and on the second piece, leave the first one alone, take the derivative of the second. And that's going to be a much easier side to do because 5x squared minus 1 power 4, leave that alone. Sure, I don't mind leaving that alone. And then the derivative of the second is just 2. Cool. That's not all that difficult either. So we're comboing these things together. If you have a good understanding of what is the product rule, how do you do the chain rule, then these steps aren't really rocket science steps, okay? It's a little bit of, right here, we did 4 minus 1. Right here, we did 5 times 2. And that was really like the math that we did. The rest of it was just all organization. So it's all about kind of understanding the organization of the rules, where you need to go next. The math is not super difficult. Now, we've done the derivative. It's time for the algebra. It's time for the reordering. This is a mess. This probably could be made a little bit nicer. There are things that we could multiply and stuff, and particularly this plus sign needs to be respected. It is splitting up these two terms. All of this is like one term, and all of this is like another term. And so we need to kind of work with this term and work with that term a little bit. So for example, something that we could probably do is like this 4 and this 10, right? We could make that a 40 if we wanted. Those two things are next to each other. That wouldn't be very hard to do. But really, to Bian's point from earlier, 5x squared minus 1, 5x squared minus 1. We have very similar pieces on both terms. And so really, if we actually want to mess with this at all, a GCF is going to be making our life so much easier. Noticing that left and right terms are sharing a lot of stuff. If we pull those out and undistribute those with GCF, that is really going to be our kind of go-to simplification here. So that's what I want to do. I want to do some GCF and undistribute, pull out as much as I can from both sides. This left side, 5x squared minus 1, it has 3 of them. And the right side, 5x squared minus 1, it has 4 of them. So what is the least common factor, or the greatest common factor, I should say? What is the GCF that we can pull off? We can pull out 3 of them. 5x squared minus 1 cubed. This person can afford to give away 3. This person can also afford to give away 3. And so we can pull out 3. Is there anything else that both terms have in common? There is one other thing. I mean, this side has a whole bunch. This side has very little. We've already gotten rid of 3 of these. So what about that 2? Can both sides donate a 2? Sure. So we can also take out a 2. So let's see what just happened. This person gave away 3 out of their 4, and they gave away their 2. The only thing they have left is 5x squared minus 1, just one of them. This person over here gave away all 3 of their 5x squared minus 1, so they don't have any more. And they also gave away one single 2, which means we're allowed to take away one single 2. So not a 2 from the 4 and a 2 from the, but just one. I'll take away from this 4 and put a 2 there. So this side over here should have, I'll write 20x, because I'll just do the 2 and the 10 together. 20x parentheses 2x minus 9. Now that we've done GCF, we've pulled out this 5x squared minus 1 cubed, and we pulled out a 2. This part is kind of like the back of our mind. We're not really stressed about that. This part is very near to getting a lot, a lot simpler. A little bit of distributing, a little bit of combining like terms, and inside there, it's gonna look like a nice trinomial from Algebra 1 or Algebra 2. So let's finish this, and we're gonna get dy dx is equal to 2 parentheses 5x squared minus 1 cubed. That's all of our GCF that we pulled out. Inside here is going to be 20x times 2x is 40x squared. 20x times 9 is negative 180x. And then we can just push all this stuff together. 9x squared, negative 180x, and minus 1. Now, I don't think we're getting any nicer than that. I think that is as good as it gets. That is as beautiful as it's going to get. And again, we can kind of think about, like, how worth it is that? If the question just wants you to use the derivative up here is just as usable as the derivative down here. It's a little bit uglier. You might have to be a little bit more careful when you use your calculator and you input a number or whatever. But all we've done is just beautify a little bit. And so you kind of get that expectation of how far do I need to go. This GCF strategy is our strategy. So you need to make sure you know how that works in the event that you desperately need to simplify. All right, we've got 3 more questions, but this one is our last one that's going to take a little bit of time. The last 2 are really quick ones. All right, y is equal to sine of 3x over cosine of x squared. So like I said, they're gonna give you a chain that is used in conjunction with a product or in conjunction with a quotient. And so here we are, we have a quotient. This is a non-trivial and so we're gonna, while we do derivatives, we're gonna need to be using chain rule for both functions if we take the derivative. So let's get into the quotient rule. Nice long fraction. Low, cosine of x squared, squared, low, cosine of x squared. We haven't taken any derivatives yet. So no chain rule yet. No derivatives means no chain rule. That is the quotient rule of low. Here we go, d high. So now we're gonna take the derivative of the high. Derivative of sine is cosine. Leave this locked up, don't touch it, and then eject the derivative. Low, d high, minus high, d low. The derivative of the low is cosine. It's going to be negative sine. We have a non-trivial interior, so it's also going to eject out afterwards a 2x. Negative sine of x squared, 2x. Again, truly, based on taking derivatives, it's not difficult.
2x or 2 plus?
What is the derivative of x squared?
2.
No,
2x.
2x, right. If it was x squared, the derivative is 2x. If it was 2x, the derivative is 2. So, just a little bit of a brain fart, no big deal there. And that's the thing about this, is it's just about staying organized, and you're almost juggling, and it's like, just keep it cool, keep it easy. This one is a mess. I don't really see anything that looks super worthwhile as far as simplifying. Cosine of x squared, cosine of 3x, sine of 3x, sine of x. I don't really see a GCF really being valuable, because I don't really see much that these two terms share in common. The one thing that I probably want to do is both of these negative signs multiplied together should make a positive sign. Like, we probably don't want to leave that. This is a multiplied by a negative. It's not a minus, so maybe my writing there should be a little bit better as well. So I probably would go for one more line. Cosine of x squared squared. And I would just tidy up, like maybe I bring this 3 to the front. 3 cosine of x squared cosine of 3x. But the real big thing is I probably want to take these two negatives and make it a plus. That's definitely going to be an improvement. Maybe I'll put my 2x to the front as well. So 2x sine of 3x sine of x squared. That does look a little bit nicer. It is a little bit more organized. It didn't take me that much work. I probably would go this far. Okay. We good on this? We got 2 more, and these are quick ones. Okay. Doing these last 2, definitely worth your time, worth your focus. I have never taught this IB class before, but I've taught regular calculus, I've taught AP calculus, and derivatives like these are ones that separate kids who, do okay, and, they get B minuses and some C's, and the kids who are like, yeah, no big deal. Because this question is an easy question. This question is not one that should typically give us problems. This is a question that we can do in our head. And it really it shouldn't be, grinding our gears in our brain too much. But when you first look at it, if you don't have the guts to tackle it, you might be thinking, ew, natural logs, gross. I don't like natural logs. But again, just relax, tackle the problem. It's not actually that hard. First of all, I do want to make sure I go over, this time I just wrote it like this, d dx parentheses. That means do the derivative, right? Because typically it would say dy dx equals, that would mean this is the derivative. But if it just says d dx, that means do the derivative. So we're going to do the derivative. Dy dx is equal to, and before we can tackle this, again, this is a natural log. That's all it is. It's a natural log with an interesting, non-trivial, interior function, whatever. That's not really a lock, but whatever. I guess at this point I've committed to the lock thing today. There you go. What is the derivative, right? F of x equals ln x. F prime of x equals, what's the derivative of natural log of x? 1 over x. We better memorize that, please. 1 over x. And that's not a hard derivative at all. So when we go to take the derivative of natural log of anything, what happened to the x that followed the ln x? Just went to the bottom. So what are we going to do with all of this stuff? Just put it at the bottom. That is not a hard thing to do. In fact, that's a pretty easy thing to do. If I could write my numbers in the correct order. Okay. That's the derivative, but this is an interesting non-trivial interior. So what is it going to do? It's going to eject out its derivative, which is also not hard to do. What is the derivative of 5x cubed plus 2x squared? Right, 15x squared plus 4x. And that would be on the end, but then we could just move it up to the top, because that's what. So let's just write it right on the top. I guess I'll write it in green, because this is also a derivative. 15x squared plus 4x. And that's it. That's the derivative, right? Again, you can be a student who's like, natural logs, I just don't know how to do those, man. But in reality, just put it on the bottom, put the derivative on the top, right? We know, we've memorized that the x just goes to the bottom, so just put this whole thing onto the bottom, eject out the derivative, which you might as well write on the top, and there you go. Now for this question, just because we're doing this question, we could also simplify this a little bit. Every single piece of this entire fraction has an x to give. This one has 2 x's and 1x and 3x and 2x. They can all give away an x. So for this question, we could simplify it. We could get rid of an x on every term. And so dy dx is equal to, just get rid of one of the x's on everything. 15 regular, stop that, plus 4, 5x squared plus 2x. And there we go. It definitely, we definitely would want to do that in a normal question. Now that doesn't happen every time, but for this question it does happen. Okay, one more. We've done natural logs, and so let's see one more of our funky things that might pop up. Y is equal to e to the power of x power 4 minus 3x squared plus 9. So that's everything up in the exponent of the e. Now, for this question, do we need product rule? No. Do we need quotient rule? No. We do need chain rule, but again, chain rule isn't a long process. Chain rule doesn't require us to do new stuff. Chain rule just requires us to be organized. When we go to do this, it's going to remind me of a plain old e to the x. And if f of x is e to the x, what is f prime? E to the x, everybody's favorite. So at first, lock this down, don't touch it. Y prime is going to be, don't touch it, leave this alone. Nobody's ever made a worse 9. Goodness. Now, eject the derivative of that thing that we ignored before, which would be 4x cubed minus 6x. I think that's good. Now that is not up in the exponent, that's just down as a normal piece. It just is multiplied afterwards, after the fact. Making this one better? I don't think so, right? Again, if you want it to be goody two-shoes, really practice, maybe you do this. I don't know that that's, improving your quality of life very much, but maybe it is just marginally better. Chain rule. Take your time a little bit, move cautiously, leave it alone, do the derivative, but don't be scared of it, especially for these natural logs and e to the x. Those are questions that I put on the quiz, that the other teachers put on the quiz, because they shouldn't be hard. But a student who doesn't try that much makes it kind of hard. Okay, done with the notes, done with chain rule.